So in this video we're going to look at subtracting two numbers, one from the other, and keep it to fairly straightforward numbers, the sort of things that we're going to get in an exam. So let's start with three-figure numbers. So if we take something like 674, and subtract 485, how are we going to do that? Well, normally people would go immediately for a column method, and we're going to do the same just to see how that works. If you were to try and do that mentally, it would be too difficult for most people. So this standard algorithm ought to automate the process and make sure that we get the right answer quite quickly and without making any mistakes. Let's see how it works. So the 5 from the 4, well, people say won't go. We're going to question that in a minute, but we immediately get into this borrowing method. So we take 10 from the 70 here, write it as 6, so we're in the tens column. That actually means 60, but we've now got a 10 in our hand, as it were, and we can write that here, so that 4 becomes 14. This is how the standard algorithm works, and 5 from 14 will give us 9. Again, we've got 8 from 6. Well, we want to increase that 6 so that we can take 8 from it without going into negatives. So we borrow from here, giving us 500, take our 100, add it to our 6 to make 16, and 8 from 16 is 8. Of course, it's actually 80 from 160 gives us 80, but when we're thinking in the algorithm, we're thinking about the value of the digit, not so much about the what it actually represents in the place value column. All right, and 4 from 5 is 1, so we end up with 189. Fairly straightforward, but a bit messy, and it's interesting to look at other ways of doing this. So what if we went left to right instead of right to left? There's quite a few advantages in doing this, the main one being that it's how we think, it's how we speak. 674, we don't say 4 and 70 and 600, so it's sort of more intuitive. Well, let's see how it works anyway. So we've got 400 from 600. In this method we must bear in mind what these numbers actually represent. These aren't digits, they are 400 and 600. So we've got 400 from 600 giving us 200, and we just write that down like that. We've got 80 from 70. Well, 70 is smaller than 80, but I'm not going to worry about that, because I think most of us realise that 80 from 70 will just take us into the negative, and it gives us a negative 10. So we'll write that down. 5 from 4, well, again, perfectly straightforward. I'm just going to put up the number line here just to illustrate this one. So obviously 5 from 4, well, here's our 4, just means counting back 5 until we get to negative 1. So we ought to know this pretty well by now, but just in case, just to think about how we conceptualize this, it's the number line, that idea that enables us to do this. So 5 from 4 is negative 1. Well, then we deal with the negatives first, I think. So we've got 200 take away 11. And we ought to be able to do that quite easily in our head to get 189. But if that's, this is when alarm bells ought to be ringing. You can easily, all of us can easily slip up here, make a mistake. So it's very important to do the mental check and add what we took away, add it now to our answer, and see if we get to 200. Then we'll know we're correct. Well, 189, add 11, is again something a little tricky to do, and in the last video we looked at this idea of changing the numbers. So I'm going to up that by 1 and then decrease that by 1. So we end up with 190 plus 10, giving us the 200. That gives us the confidence that we got that correct. So it seems to be a relatively good method, but it's not necessarily something I'm recommending. The standard algorithm, as I say, works. If that works for you, fine. The expanded method here has a lot going for it, but when it gets into larger numbers, maybe that's going to be trickier. What I suggest you do then is write down some numbers of your own. Write about 5, 10 sums or subtractions here, so that you can try out how well it works. It ought to work at whatever size of number. It ought to work with decimals, and you will need to try this out if this is new to you. But it's a way of thinking about what we're actually doing here and not straying too far from mental subtraction, which is extremely important to practice. Now I'm going to look at the sort of numbers you might get in an exam when things are often mixed up. So addition and subtraction frequently goes together. And what we're talking about here is a string of numbers, usually horizontally, where there are some subtractions, some additions, and we need to sort these out. Now that looks like a bit of a long string. We might be worried about doing that, but I don't think we'd leap for a column method to do this. That would be extremely messy, although people used to do it in that way. I think what we need to do is have a good understanding of the methods we can use. We need to be fluent in number to be able to sort this out, simplify it, and do it pretty quickly and rapidly. So the first thing I'm going to do is I'm going to start commuting these numbers. Now this immediately raises an objection. If I just change the ink color here, I think a lot of people know that with addition it's perfectly okay to commute, but with subtraction, so when you're dealing with negative numbers, people get worried. And they're quite right to think about this carefully. The issue with commuting is when we've got addition, if we have 5 plus 3, let's say, then 5 plus 3 is the same as, so we put 3 lines here, we use the symbol for an identity, it's identical to 3 plus 5. In other words, it doesn't matter what order we do this. That 3 can come in front, 5, and so on. With subtraction, it's pretty well known that we don't get an identity when we swap these two around. So 3 subtract 5 is not the same as 5 subtract 3. So we say this one is you can commute, addition you can commute, and subtraction you can't commute. Well, that's certainly true. But we're going to move the order of these subtractions nevertheless, and we can do that because as long as we're subtracting the 42 from the positives here, or the 15 from the positives, as long as we're subtracting it, not putting it up front so it becomes a plus, then we're perfectly okay to move it around. So, for example, if we put, to make life easier, well, let's put the 91 up front. It's generally a good idea to have your larger numbers in front. I think because, whether you're doing subtraction or addition, I think it's because we like to think in terms of counting on or counting back, and so the smaller number usually goes to the right. But so we've got our 91 up front, and what we're going to then do is write out the rest so we can see what we've got here. I'm going to just put brackets around this. I wouldn't normally, but we can see now we've got an easier subtraction here. We've got 42 from 63. If we'd have tried to take the 42 from the 91, that would have been harder. So it made sense to swap it around. We've now got the, well, let's do the 37 bring that up to here and put our negative 15, and then finally do our 12. Okay, so that's rearranged it so that we can do it much more easily using just mental arithmetic. So we've got 91 plus, sort out this bracket first, 21. Then we've got 37 take 15 is going to be 22, and our 12 at the end. Everything looking much simpler now, so we can just keep fiddling around with this until it works itself out. Let's just start with that 91. I'm going to join the 21 and the 22, I think, so it's 43 plus the 12. Yeah, that's going to be very easy. So 91 plus 55. At this point I could make a mistake, so I'm just going to pause, not go too fast. Remember that we can change the numbers if we want, so we might want to make this easier for ourselves by increasing the 91 to 100, and if we've done that, we've gone up, then we must go down with this. So we went up by 9, down by 9 then, and we end up with 46. So the answer here is 146. I think it's worth doing quite a few of these, and I would encourage you to write these out and practice and practice and practice until these were pretty automatic and you can do them very quickly. Remember, the important thing is not to go too slowly, where you can speed up, but when you can feel yourself, as we did here, when you can feel yourself taking risks with a calculation, then go to one side, write it out if you want to, or just make sure you've got that right. We must be certain that our answer is correct, so we went up 100. Little risky thing here, 46. Are we sure that when we take 9 from 55 we get 46? Just keep calculating until you're absolutely certain that you've got the right answer. So that's what happens, the sort of thing that's likely to happen when you've got negative numbers and positive numbers mixed together. Okay, so some methods there for subtraction, some thoughts about how to think about subtraction, the issue of commuting, when you can do it, when you can't do it, and what that means for taking away. And if you wanted to find out some more or think about this more deeply, the second part of the video is going to go into the theory behind this. So let's now look at some of the ideas behind, some of the theory really behind what we've been doing. And I want first of all to look at this idea of increasing one side and decreasing the other, this upping and downing as I've been thinking about it. And we want to look at that for subtraction because we haven't really examined that yet. And secondly, we want to look at this issue of borrowing that we do in the standard algorithm. Why is it that we feel we have to borrow? What's going on there? We'll look at some of the ideas behind that. So we're going to start with some algebra. So here, instead of numbers, we've got A and B. So we've got any number A added to any number B. If we want to change those numbers and preserve the same result, so in other words, if it was, as we've got in this example, if it's 3 plus 8, but we wanted to change it to 4, so we go 4, then this one has to come down. 4 plus 7, both give us the result of 11. And so why is it that that happens, and what happens when we come to subtraction? Well, first of all, it's quite easy to think about, I think, increasing this brick here. So let's just draw that in. So we've got another brick that we add to the top here, which gives us 4 bricks on this side. and here I'm going to struggle a little bit with my graphics, but we've got 4 bricks here, and we've said that if one side goes up, the other side must go down. So we're going to just scribble this one out. And so we've now got 4 on that side and 7 on this side. So why is it that it works out that way? Well, because addition, what addition is you can think of it as counting on, but I think a better way of thinking about it, or another way anyway, is it's about joining 2 piles together here. In this case, piles, 2 numbers together. So if we join these 2 together, then we don't want to change the total number of bricks. So I think it's fairly easy to see if we think of it that way, of joining together these 2 piles, that if we increase that, then we must decrease that. The total number has to be the same. So one side goes up, the other side goes down, or vice versa. Now the thing about subtraction is it's all about the difference between the heights. So let's just erase our bricks here, and perhaps draw this a little bit more carefully. So it's all about this distance here from the top brick of each pile. We're saying what is the difference, and the difference of course is 5. The difference between 8 and 3 is 5. So when we subtract one number from another, and we want to keep the result the same, we have to make sure this difference remains exactly the same. So if we are, let's just erase these numbers here, if we're going to say 3 from, there we go, so 8 subtract 3 equals 5. If we're going to, let's say, increase this large pile here to 9, so this one's going up, what have we got to do to the other one to keep the difference the same? Well, let's have a look. Let's just add a brick on top here, so that difference now has become 6. We want it to be 5, so we have to add a brick onto this pile as well. Now, if I look at the difference that we've got now, it's still 5. It's 5, even though we added a brick onto each pile. And so, having thought it through in concrete terms, in abstract algebraic terms, what we've got is a nice rule here. If it's subtraction, when you increase one side, you also increase the other side. Or if you decrease this side, you would also decrease this side. So it's the inverse of addition, and that follows what I think we know about addition, that addition and subtraction, they have an inverse relationship. An inverse relationship. Well, that's a rather nice result, because it means that as long as we practice this, we just need to learn that in addition, one side goes up, the other side must go down, that it's the opposite in subtraction, that the same thing, it's almost easier with subtraction, the same thing happens to both sides. So that's the first part of what I wanted to do, dealt with. The second part is to do with this idea of borrowing. Why is it that we borrow? Let's just erase all these marks. Why is it that we borrow? Let's keep this one actually. Well, the reason why we borrow, let's do it this way, the reason why we borrow is because we're worried about taking a smaller number, taking a larger number, from a smaller number. So that's why we do this borrowing thing. Remember, we've got 26 and 17, and we say, well, we can't take 7 from 6 because 6 is too small. Whereas in the expanded method, we just say, well, there's no problem. we can easily take 7 from 6. It just gives us a negative number. So what I'm going to look at here is why it is that we are still in the modern age worried about negative numbers. And this has been a problem for a long time. You can see why. If I think about my bricks here, well, I've got 1, 2, 3 bricks on the left here. What would it mean to take 8 bricks away? If I take 8 from my 3, well, then I have to think about negative bricks. I don't know, maybe I'd write them underneath here as kind of ghostly bricks. But really, it's not an easy thing to think about. It's not a natural thing to think about. And so in this example, at least, it seems very strange to think about negative numbers. And that's because we're in a world here where we are just interested in counting these bricks. If we count our bricks, we are still in a set known as the natural numbers. And we write this letter N to stand for the natural numbers. The natural numbers start at 1 and go up forever. But they have a starting point. There's nothing below 1. In other words, there's no 0. Whereas the integers, and we give these the symbol Z like this, the integers, they don't have a starting point. They have a middle point, which is 0, and then above that we have the natural numbers, so they're included, but it can go in the opposite direction forever as well. So here we go. So unlike the natural numbers, the integers don't have a beginning and end. They go off forever in either direction. So it's when we're thinking just in terms of the natural numbers or the counting numbers, which is how we also talk about them, the numbers that we use for counting, we're not generally thinking about 0. 0, in fact, is quite a recent invention. It was a medieval invention, so that for thousands of years there was no concept of 0. The integers include the concept of 0, which is a kind of ground level, if you like, and this sort of below stairs floors going down and down and down forever, which is the set of integers. That's not to say we can't represent this concretely. I thought of this example. Here's a jar. If we set this as ground level, in other words the level of the liquid here, then we can easily think about, well, if it goes up, it's going into the positive, but equally it might go down, and so we're going into the negative numbers. So it's because we tend to think of counting numbers as being natural and objects and things that we count as the basis of our mathematics that we find negative numbers so difficult. Whereas in fact there are lots of examples where going up and down through the 0 point, the centre, sometimes called the radix here, is quite natural. Going up and down in a lift was the example I was given there. You might think of going backwards and forwards in a book. There's lots of ways to help us think about negative numbers, but that's what we're doing. We're working with the set of integers, which is what allows us to go up into the positives, but also just as easily down into the negatives and backwards and forwards across that 0 point, which takes us from positive to negative. Okay, I hope that's helpful as a way of thinking about why it is we do the things we do and what exactly we're doing with numbers and why they work in the way that they do. Obviously, the purpose of this is to help you with calculations, making sure your calculations are more effective, more efficient, faster, and most importantly, reliable. So do please go ahead and practice until you're absolutely secure in both the idea of the number line and the set of integers, but also being able to calculate and get the right answer. And once you've got that securely under your belt, then move on to the videos on multiplication and division, where there'll be more ideas using algebra, but also more practice, more methods for multiplying and dividing, hopefully in efficient, reliable and effective ways suitable for use in exams.